Hey, how's it going? Been a while, huh? So I had been doing some horse trading over the last, year and a half, and ended up with a bunch of other things that, maybe someday I'll show. I had traded a bunch of stuff to my buddy Dave, who lives out in Pennsylvania, and I said goodbye to my big IBM S34 and some smaller IBM gear and a solid-state disk array. And in return, he gave me some Sun gear and some other bits and pieces that I'll try to do a video on. And I thought today we could talk about the Sun mid-range servers. And much like that palette of octanes, where really only wanted one or two, and one or two are good, 15's definitely got to be better. I ended up with a reasonable group of the family. The mid-range servers from 2001 through 2005 were made up of the 3800, the 4800, the 4810, and the 6800s, which are the big dogs. And so I have a 3800 here, and a 4800, which is in here. And rather than just get one 6800, well, kind of had to end up with two of them, of course, because spare parts, being what they are. So we have a pair of 6800s here. I've got one front ways and one back ways, so we can take a look at them. The mid-range servers, as I said, came out in 2001. This is the series on from the machines that were around in the E10000 time period. These are mid-range, so that means that they're not HPC or the big high-power computing like the E10K, which is in the back there behind this rack. They are mission-critical, run your business off them, but not supercomputer like this generation's HPC, which was the Sunfire 15K. The smallest, the 3800, could contain two system boards, which is a max of 8 processors. The 4800 could do 3, so that's 12. And then the 1600s could take 6, which is 24 processors each. And pretty impressive. What they have done, though, in all of these machines is retain the reliability and the redundancy that the E10K exemplified. The E10K, of course, was brought over by Sun from SGI X Cray, because it was designed by Cray. When SGI purchased Cray, they sold this machine to Sun, because it was full of Sun processors. The Cray engineers that designed it made it for not only complete throughput, but high fault tolerance. And they've abstracted a lot of those lessons into these machines here. So where you have multiple system boards, you have multiple fan trays, repeater boards, I/O buses, power supplies, all those sorts of things. Now, of course, to a limited extent, the lower-end machines take that to a limited extent. As the machines get bigger, obviously the amount of space that you have means that you have more room for more fault-tolerant devices. We'll take a look at the 3800 now. We can start with that and move on to the 4800 because those are the low-end machines, but they still end up sharing an awful lot of the hardware with the big-end machines, which is awfully convenient. So the 3800 and the 4800 are the two smaller of the units. There's also a 4810, which is a 4800 that is rack mount only. The strict 4800 can be rack mount, or it can be desk side chassis. Why they differentiated them, I'm not sure. There must be a difference, but for the life of me, I can't find it. So the 3800, and if you'll ignore these empty cases here, which are for PDPs, the 3800, the front of the unit, we have, well, first of all, we have a disk array, which is this thing down here. That's actually a NetApp device and completely unrelated. It was a bonus. The 3800 is this chunk here. So we have the two system boards here and here. We have the system controller, and then we've got a compact PCI bus down the bottom, or a compact PCI chassis. The mid-range systems could have either compact PCI I/O subsystems or PCI I/O subsystems. Now the 3800, primarily for packaging, but also for cost, has a lot of the really clever things that are on the bigger systems shrunk down in different places. The system controller on this has a lot more bits and pieces on it that are taken from other boards. The repeater boards, which are in the bigger systems, which I'll get to in a bit, they're actually on the back plane in this. The compact PCI chassis in here, unlike the other machines which can do PCI or compact PCI, this can only do compact PCI, and the compact PCI chassis in here doesn't match anything else. Little inconvenient, but it is a cost-reduced system. A Midland configuration for a 3800 is about $100,000 to $150,000 in the year 2003, I believe. So not inexpensive by any means, but 8 processors, baseline at 750 megahertz. They topped out at 1200 megahertz with the UltraSpark 4s. Very, very powerful machine nonetheless. With the dual system boards and with the way that the system is designed for redundancy, you can lose processors, you can lose RAM DIMMs, you can lose an entire system board, and the system will keep on ticking. You tell the system to drop system board, pull it out, repair it, replace the bad RAM, throw it back in, tell the system it's there. Solaris moves back to it, and you're away laughing. So, again, this is the limited system, still highly redundant, highly fault tolerant. Now, the 4800, which they came in these nicer racks like the 6800s. Well, the front of it's not too exciting because in behind here, which of course is closed, the only thing that's in here is the power supplies. 3 big chunky power supplies, which, much like the 3800, don't match any of the systems whatsoever. And although they look enormously tall, they're actually about this deep. This system also has another lock disk array. This is a storage T3, and we have a bunch of 3.5-inch discs right there. Another bonus that came with it. The interesting stuff is on the back, and hopefully I don't destroy anything while rotating it. Like my back, for example. Alrighty. So, now we have something a bit more interesting. What we have are the 3 system boards. We've got one missing here, and this is a blanking plate. This is the system board here. We have the repeater boards, and we have our PCI subsystems here. A couple fan trays. And then this is the distribution panel for the power supplies. And then finally at the bottom we have something that you can't actually see. Let's tip this forward a bit. This here is the AC power distribution unit in the sequencer. And we'll get more to that in the 1600s because they have them as well. But basically you plug high amperage cables into them, and it will sequence with the rest of the system and the frame manager. Again, I'll get to that in a bit. The 6800, the big dog, shares with this system the system boards, the repeater boards, the system controllers, which are here, which I missed before, and the PCI subsystem. So already there's a huge number of replaceable field units that go back and forth. The system boards have a really delightful little catch on them. Once you use your screwdriver to pop and release, well, here, there we go. And it makes a horrendous noise, and I'm assuming it's supposed to. here. And so we have the 4 processors underneath this grill here, a large amount of RAM, cache, and then all of the controller ASICs hiding behind here. Put this back in. The PCI boards, or sorry, the PCI subsystems, 4 thumb screws and then a couple of ratchets, and they pop out. The PCI subsystems, like the compact PCI, are completely self-contained. So you have the power supply for the entire system. All of the cards in here are powered from this. You've got DC-DC converters because the system runs on 48 volts. So this brings it down to the voltage this power supply can run. A couple more DC-DCs. And we've got a ID PROM in here so it can identify all of the subsystems individually. And these are all 64-bit cards, and it'll do full length, and then the shorter cards. It'll also, of course, fit the 32-bit cards. Put this back in. We've got our 2 system controllers and our 2 repeater boards. I'm going to go into all of these boards in greater detail in another video to try to keep this one short. But briefly, the repeater boards are what switches the packetized bus. All of these things are connected to a center plane that has no logic on it whatsoever, unlike, for example, the E10K center plane, which has a ridiculous amount of ASICs covering it and is some 48 layers because of the complexity involved. This is just a very simple, dumb center plane. All of the intelligent bus switching and bus handling capabilities are on the repeater boards. The system controllers act kind of like the SSPs in the E10K, where the E10K required a system service processor to bring the system up to get the PROM going, because the PROM code was stored in the SSP and it was ran across via Ethernet and then JTAG'd to the system boards. The system controllers on this contain their own Sun SPARC processor. They have all of the boot code built in. They run VxWorks in Java. And so when they boot, the Sun processor comes up, they will system check the entire machine, and then they can provide boot code as well as configuration to all of the system. The bigger machines are more of the same, but even more complicated. So I've popped open the doors. We have front of the unit, back of the unit. We have the rack itself, the frame. We have the D240. We've got system boards, fan trays, power supplies, the AC input boxes, which are at the bottom, front and back. On the back, we've got the patch panel, fan trays for the rear of the unit, the repeater boards in the center here. We've got the PCI buses. On this side, we have, and you can just sort of see the cabling here, the system controllers. This lovely hexagonal vent here is the output for the exhausted air. We'll start at the top. So on the top of both these units is, well, in fact, all 4 of these racks, is a frame manager. And it's a key switch driven device which, when you power the AC input boxes on, so you slap in the cabling, flip the switches, there is a small internal breaker that'll click on. The power supplies will check the voltage, make sure everything is good. Frame manager will light up, the fans will come on. Next, you'll flip the key switch on the frame manager. Frame manager's got its own SPARC processor built in. It'll do a system check on all the voltages and it starts bringing up the power supplies because it flips the main breaker inside the AC input boxes. Like the E10K, this has an internal system voltage of 48 volts. So the 248 volts comes in through the AC input boxes, goes up into the power supplies. That's what these cables are here. That's the output output cables for the AC input boxes. The power supplies dump from 240 volts down to 48 volts regulated power. And then all of the devices either run at 48 volts, like the fan trays, or the system boards, repeater boards, the I/O subsystems, the system controllers, which are in here. They will bring voltage down to the necessary voltages required. They've got the DC-DC built in, like I showed you on the the PCI boxes. The D240, one of these came with each rack. Well, I've stolen it from this one here. It is two 5 1/4 inch bays, and then in the center there's two 3.5 inch removable hard disk bays. And so in the case of this one here, I've got a pair of DVD-ROM drives, and in the center I've got two 36 gig SCA SCSIs. You can use these to boot the system. So use the DVD-ROM drive to install Solaris onto the local internal disks. Your system will boot, and then you can use the network to connect to storage NASs, things like that. So this is supposed to be just enough to bring the system up, and then all of the big data and things like that are connected to via a SCSI cable, which you would have a I/O PCI card for. If we'll get a bit closer, we can start at the bottom. So first we have the AC input boxes down here. There is one box for each side that makes up half of the power distribution bus. There are two input boxes per side, or input supplies per side. They use these rather glorious looking power connectors here, which you connect like so. Check under, and then this will latch it on. Now, normally, of course, they would have some twist locks on them, but because I am cheap and difficult, I put outlet connectors on them, NEMA 15 30Ps. So that means that I can run them off all of the power cabling that I already have in here. We have the power supplies, fan trays further up, and then the patch panel and the distribution box. So the front AC units will power 3 of the supplies. The rear units will power the other 3. So if you have one unit fail, you should still have half of the supplies. Actually, I lie. I am mistaken. It depends on how it's wired up. That's what these are here. They'll run to the devices so that you can sequence the power, as well as the frame manager. You can use one of these to power this 3, that one to power those 3, and then the reverse on the front and back. So if you lose one, you should still have one input box powering your 3 supplies. Keep all 6 running. You have 3 per power grid, so you can lose 1 or 2, obviously depending on load. If you have one system board, only 2 of the repeater boards in, you can run the entire system off a single power supply. This patch panel on the back here connects the system controllers to the rest of the system itself. You have 2 Ethernet connectors. You've got the input RS-232 cable that comes from the system controllers around, and then A and B serial ports. What does that mean? Okay, so there's 2 system controllers. So the idea is that obviously if one fails, you have a replacement. This side is the first system controller, that side is the second system controller. System controller 0, system controller 1. The input cable, which comes from the system controller from the front of the rack to the back of the rack, carries 2 serial. It also carries an Ethernet. So you can connect to the system controller via Ethernet or via serial. I use serial because I'm traditional and difficult. The serial in goes in here, out goes back around. Now in that case, that one goes to the AC input box. So the AC input box uses the serial to communicate with the system controller, telling it when voltage is stable and it's good to go. So first the front of the unit. we have the 6 system boards, and they are numbered rather curiously. 0, 1, 2, 3, 4, and 5. In my case, I have a banking plate here. The system boards contain either UltraSpark 3s or UltraSpark 4s, and you cannot mix the two in the same domain, and I have them all in one domain. And I'll get to that in the detailed video. On here we have the 2 system controllers, so they're embedded back in. We've got our big thick A and B cable and then our Ethernet. On the rear unit you can see we've got our 4 repeater boards, so the bus is bit sliced across all these boards to give us full connectivity between all of the devices. It's a crossbar type switch, and we've got our 4 PCI subsystems. I've got a SCSI card here, we've got some fiber channel here, and then some fiber Ethernet. When you replace some of these devices, there is a certain window of time for when it begins to overheat. So they provided blanking slots like this. So if you pop out a I/O unit, you're supposed to slap this in here. That'll blank it so that the air running up through the fans and out to the exhaust doesn't all leak out, and you're not going to overcook anything. There are blanking plates for the power supplies, for the system boards, as well as fan trays. Well, I think that's enough for this one. It's been a bit rambling. I apologize. It's been a while since I've done one of these. I'm going to follow up with a more detailed one explaining how the repeater boards work, things like that. We can take a look at them and the basic bus architecture that it uses, and then we'll go on to trying to power one up. Alright, I know it's been a while. If you have been watching, thank you very much. Hope you all have a fantastic day. Take care.